given a histogram, we can find descriptive statistics for that histogram. So going to the example of the number of defects per hour in a manufacturing plant, we want to find the mean and median for the number of defects found per hour. Okay, so if we want to find the mean by hand, remember that all a histogram is doing is taking each of your data values, adding them up, and dividing by the number of data values. So if you wanted to do this by hand, you could. It's a little bit tedious, but you could do it. So 2 defects occurred about 2 times. So essentially what you're doing there is taking 2 plus 2. And remember, a fast way of adding 2 plus 2 is actually multiplying 2 times 2. And then you would add to that the next one, 3, occurred 16 times. Well, instead of doing 3 plus 3 plus 3 16 times, you could just do 3 times 16. And then 4 defects occurred about 7 times. So instead of adding 4 plus 4 plus 4 7 times, you can add 4 times 7. So you can go through all those. I'm not going to, for the sake of time, I'm not going to go through all of these, but you could keep on going through your histogram and do that same process. The numbers in the parentheses that I have, those are your frequencies. So once you add those up, 2, 16, 7, and so on, that would be what you end up dividing by at the end. Okay, so the sum of the frequencies is what you would divide by at the end. Okay, if you want to find the mean by hand, we use our calculator. Okay, so what you would do, and you're going to notice that when I go to the correct menu here, that I'm going to have values in my list already because I already put these in for the sake of time. But what you do is you go to Stat, and then press Enter to edit your list. And you put your X value, so the number of defects in list 1, and the frequency in list 2. Okay, and again, I already have these in here along with other lists just to save time later on. So X goes in list 1, and your frequency goes in list 2. And then what you want to do, if you need to pause the video to catch up, go ahead. But to find the mean, you press Stat, and then over to Calculate, 1 var stats, and I have the values, I have the X values listed in list 1. So I want to do 1 var stats on L1, so second 1. Okay, so again, notice how L1 is above 1. So that's where I have the X values, the number of defects. And then comma, second 2, because I have the frequency in list 2. Depending on your operating system, you may have X list, make sure you put list 1 in there. And then you may have a option that says freq, F-R-E-Q, that means frequency. So that's where you will put your list 2. Okay, press Enter, and it gives us our descriptive statistics. It gives us the sample mean is 6.05. Our sample standard deviation is 2.50. Okay, so X bar is about 6.05. The standard deviation, I asked you that in the second part, so I'm just going to write that down here now. S equals 2.50. Okay, now once you put the values in a list, your calculator will also find the median for you. Okay, so the first question, I asked you the mean and the median. So to find the median, you scroll down and notice it is, median is 6. Okay, so the middle data value is 6. Okay, the way to find that by hand is we have 78 data values. So n is 78. So our sample size is 78. If you do 78 plus 1, that's 79 divided by 2. So the location of the median is 79 over 2, which is 39.5. So you'd have to average the 39th and the 40th data value. So you would count in to the 39th and 40th data value. So there's 2, and then 16 is 18 total, and then another 7 is 25. So you'll keep on doing that till you got to the 39th and 40th data value, and they would both be in the interval of 6, where there were 6 defects. So that's how you can find the median by hand. Okay, so we already found the standard deviation, okay, to be 2.50, and we're using the sample because we're assuming this is a sample up here for the number of defects found per hour. The range of the data, well, the lowest data value was 2, and the highest data value was 12. So 12 minus 2 gives you 10. So the range is 10. Okay, to find P90. Okay, that's the 90th percentile. Okay, so what you're looking at there is what data value has 90% of all their data values below or equal to it. So that's where you find the location by doing your sample size, which is 78. And then the 90th percentile is 90 out of 100. So 78 times 90 hundredths. Okay, do that arithmetic, you get 70.2. And again, you should probably pause the video and try this on your own. But I'm just going to keep going for the sake of time. So that means you want the 71st data value. So if you count 71 data values into the list, well, you can start on the left end and say, okay, we have 2 here, then 16 here is a total of 18, and keep on counting. Or, if we're 90% of the way through the data, we can go 7 data values, because we had 78 total. We have to get to the 71st data value, so we can backtrack 7 from the end, from the right end. So if you backtrack 7, so there's backtracking 1, and then 3 more is about 4, and then 7 would end up, 7 backwards from the right end would end up in the 10 defects per hour. Okay, so we can say that P90 equals 10. So that means 90% of the data values, or 90% of the number of defects, were 10 or less. Okay, the next example to look at is a frequency histogram where we have intervals. And one thing I want to point out is on the sheet it says 0 to 10 to start with here, and then 11 to 20. That should not happen because that's inconsistent. The first, instead of a 0 there, that first one should start at 1. Okay, and then the par should probably start a little bit to the right. Not a big deal, but I just want to point that out because your interval should always be consistent. Now what they do on this one is they label it as 1 to 10 minutes, and then 11 to 20, 21 to 30. And that's not the best labeling. I'm showing you this so I could point this out actually. What they should have done is they should have put 0.5 to 10.5, and then the next one 20.5. They should have labeled the endpoints, or just labeled the midpoints to be 5.5, 15.5, and so on. Okay, this is not the best labeling job here. Okay, but anyway, we can still use it. So this is using an interval, which is different than the first one, which is why I'm showing you this one. So to find the mean and median, okay, again, what we'll do is we'll put it in our calculator. Okay, so press stat, and then edit again. Now again, for the sake of time, I have the values in list 3 and list 4 on my calculator. So I'll just scroll over there. Okay, so when you have an interval, you have to enter the midpoint of each interval into your calculator, into your X list. Okay, so again, I already said that this should really be 1 to 10 and then 11 to 20 and so on. So to calculate the midpoint of each interval, you add the endpoints and divide by 2. So 1 plus 10 is 11, divided by 2 is 5.5. And then 11 plus 20 is 31, divided by 2 is 15.5. And from there, you'll notice that each of the midpoints goes up by 10. Okay, so you want to go through and enter your midpoints all the way up to the last one of 95.5, representing that 91 to 100 interval. Okay, and then you put your frequency, the height of each bar, into list 4 in this case. Okay, so 1, 2, and so on. Okay, and then you do very similar. Now it's basically the same thing as the first one. We have 2 lists. The first list represents your data value, the midpoint. And then the second list, or the second column, represents the frequency of your data values. So you do the same thing as we did in the first one. Stat, and then calculate 1 var stats on L1, L2, or however you put it into your calculator. Oops, I'm sorry, I did L1, L2. I meant to say L3 and L4, I'm sorry. So let me clear this out. Okay, so stat, calculate 1 var stats. I used L3 and L4 on this one. So second 3 for L3, and then comma, second 4 for L4. Okay, so we get our mean of 49.875 minutes. If we scroll down, we get the median of 45.5. And again, you can count in, if we have 32 data values, you're going to do 32 plus 1, which is 33 divided by 2. And that'll give you 16.5. So you want to average the 16th and 17th data value. And you can count in from that, and you'll see that you have 45.5. That's the middle interval. Now, sometimes they'll ask you which interval contains the median, and you could say 41 to 50 is the interval that contains the median. So it just depends on how the question is worded. Okay, and then for the standard deviation and the range, okay, the sample standard deviation is 21.99. The range is the highest minus the lowest. So it's a little trickier on intervals like this, but if you take the midpoint of 95.5 minus the 0.5 midpoint for the first one, you get 90 for the range. And then to find Q1, the first quartile, very similar to the 90th percentile in that you do it the same process. Well, Q1 is 25% of the data values, so that's 25 hundredths. And there's 32 data values. You end up getting 8 when you do that. So that means you average the 8th and the 9th data value. Okay, and when you do that, you end up with 35.5 minutes. And your calculator actually gives you the quartiles. It gives you the 5-number summary. So that does match up. Okay, last thing I want to show you is graphing these histograms. So how do you get a histogram shape onto your calculator? Okay, what you do is you notice how above y equals it says stat plot. So if we press second y equals, press enter, and we're going to look at our stat plot. We want to make sure the stat under the plot 1 it says on. Okay, so usually the off is highlighted. You want to make sure that's on. So make sure the on is highlighted in black. And then make sure you choose the correct graph. There's the bar graph. And then list 3 will be the x values for the number of minutes. And then list 4 is your frequency. Okay, then if you press zoom 9, so zoom and then stat, is option 9. Okay, it'll give us a bar graph. Now, most of the time, it doesn't give you the bar graph that you want with your intervals. If you press trace, right now, mine says minimum is at 5.5, maximum less than 20.5. So essentially, that's including any number of minutes between 6 minutes, because 5.5 is less than 6. So anything from 6 to 20 minutes. That's not what we want. We want anywhere from 1 to 10 minutes. Okay, so what we do is in our window, we can change our minimum to 1. And we'll make sure this works. Okay, so I think the minimum is 1. The maximum, we'll just say 100, and we'll see if it fits in. We should be okay based on our histogram. And then our X scale, this is what's important, how much you want each bar to be worth. So what do you want the width of each bar? Now let me put in 10, and we'll see if this works out. You may have to play around with it and see if it works or not. And the more of these you do, the better you get at knowing exactly how to manipulate that X scale. Okay, the Y minimum, remember that's your frequency. Now I'm just going to put like -1 in there, and that'll mean that the X-axis will show up on the screen. And then the maximum, well, the highest this one goes to is 6, so I'm just going to put 10 in. And then the Y scale means it'll go up by 1. And now if I press graph, okay, we'll see if this histogram is the one that we want. Okay, so let's see if it matches up with this one on the paper. So now if I press trace, that first interval says the minimum equals 1, which is what we want, and the maximum less than 11. Well, less than 11 means we go up to 10. So that means anything from the minimum of 1 up to 10 will be included in this. And that's what we have here. Okay, so notice n equals 1. So there's 1 in that column. And then if I trace over, the next one, minimum 11. So this will have any data value from 11 to less than 21. So less than 21 means they'll go up to 20. So any data value from 11 to 20 will fit in this. So that window that we used, starting at 1, and the X scale of 10, actually works for this one. Okay, just suppose I change that scale to say 15, just so you can see how it changes it. Okay, now when you trace it, now we go from 1 to 15, because the max less than 16. So that's how changing that maximum, your scale in your window, that's how that affects your histogram. So that X scale is very important to understand. So that's basically just saying your width of your interval. Okay, so that's how you find descriptive statistics on a histogram and graph them.